Today we're going to take a look at the FCT070 transmitter for Siemens Coriolis meters. This transmitter sits in an ET200SP HF I/O card or on an ET200SP CPU, and it is capable of storing 17 ABV curves for all of your applications within the distilling industry. But what became apparent was when we were looking through the manual, there was one particular parameter that caught our attention, and that was in the output block. As you can see here on the screen now, there's a parameter in the last output byte that allows you to change the fraction table. Now that parameter can be written to directly via the PLC. So we can create some code to have the ranges change automatically, or we can have a human machine interface, or even a cloud app where we can change that remotely. So what we're going to take a look at first is why we need all of these ABV curves to cover the distilling industry. Why don't we just have one and that will cover all of our applications? And it's important to realise that when you look at your standard way of producing distilled spirit, we use hydrometers, and when you look in the safe, the whiskey safe in this case, you'll see two, and there'll be one for the high range and one for the low range. So even with the conventional method of measuring density, we can't achieve the accuracy with one measurement device. So what we're going to take a look at now is all of the different measurement points in the distilling process and why we need these different ranges. On the screen now, in the forefront, we have an example of a typical Scottish whisky distilling process. So that's probably one of the largest industries globally for whisky. And in the background is another process which is a triple distilling process, but the measurements are the same and the challenges are the same. So we're just looking at the production side to start off with. So we'll start with the wash still, where we take the product from the mash tanks, which has an alcohol content of about 4%. That is heated up normally with steam coils, and then the alcohol will go through a condenser, so in its steam form, and we get a purer spirit coming out. Now the wash still, basically we start the process, and anything that goes into this through the spirit safe into what we call the low wines is measured, and the range here is 1 to 25% ABV, and that varies from different whiskey manufacturers. And when we finish the cut at the bottom, it's 1%, so that's a nice range to work with, 1 to 25% ABV. That's one curve. And the pot ale, which is the sludge in the bottom, is then used as a high protein feed for cattle farmers. So that was interesting for me to learn that cattle are being fed 1% alcohol, which is a bit like shandy bass. So the next process is the final still in this example, but again for Irish whiskey there'll be an intermediate still. What we're taking here is the product from the low wines is going into my next spirit still, and we have something called the head of the process. So the first part of the alcohol that comes through here tends to be very high, and it has other properties that we really don't want to be getting into our final product, and that will go straight back and be recircled into the low wine so it can be used again. And the first cut varies again from manufacturer to manufacturer, but it's normally in the 70% mark for whiskey, and then we carry on measuring down until we get to our final cut for the production, that goes into the spirit receiver, and that can be about 60–65%. And that's called the heart. That's what we want to use. But the process doesn't stop. We want to try and get as much spirit out of this low wines as we can. So we then keep heating the product, and the final cut can be as low as 2%. So we're getting all of the alcohol we can out, put back into the low wines, and then we'll use that again on the next production batch. And some whiskey manufacturers would say that recircling that low wines gives the whiskey a better taste. But again, all of the whiskey manufacturers have different USPs. That product left in the bottom is mostly water based, and it's really not used for anything else, a bit unlike the pot ale. So we have a range here that we have to work with on the spirit still. We have to measure probably up as high as 90% ABV all the way down to 2%. Now the density measurement and the temperature measurement inside the Coriolis meter is pretty linear in its uncertainty, so that's not where the error is. The error is actually in the OIML tables, and if you were to look at the curves, they're not linear, and that's where we get the problem. It's the actual characteristics of the process or the measurement of ABV, and the formula that it's based on is not linear, and that's why we need to have the split ranges. As you can see here, this is probably, it varies, but this is why I think Scotland is such a good market. Is they don't just put the final product into barrels. This could be like a single malt application. There may be other manufacturers of whiskey within Scotland that blend different spirits, and what you can see on some of the sites is you'll have a big 30-ton truck turn up, and it will take 30 ton of spirit away, and that will be taken to a blending whiskey manufacturer, and they'll use that to make final product elsewhere. So it's almost like a self-sufficient industry. Now that is important because there's a tax that the manufacturer of the spirit has to pay, and what I've built into this HMI screen is just a very basic means of calculating that. So let's have a look at the screen that I've generated here. So this is just a landing page, just for an example. So there's a hidden button here that takes us into the main screen. So what you can see here straight away is your density and temperature and your ABV measurement. And this is always going to measure within its stated accuracy. Unlike a hydrometer, you could get 5 people to read a hydrometer and you'll get 5 different readings, I can guarantee that. But this will be the same all the time. And then down here, this is the really nice thing, there's 2 flow measurements. At the moment I have no flow, but you have your bulk spirit, which is your water and your alcohol. Okay, so you know exactly what's coming out of your process, but more importantly, if you're on that last stage where you're delivering your alcohol to a road tanker, so you're selling it, it also measures just the alcohol. And as you can see here, it totalizes it. This is all done in the meter, so I haven't written any code to make this happen. So I have the total of bulk spirit, and I have the total for litres of pure alcohol. And what I've also added is an input screen where I can put the actual tax that I will be paying on my litres of pure alcohol. So when this starts flowing, it will also give me an idea of how much tax that I'm going to have to pay on what I've just filled into the 30-ton road tanker, for example. So now we'll take a look at the actual ABV curves themselves. As I said, this is 1 meter for all of your distilling processes. So we'll start off with the full range. What I've actually got in the Coriolis meter at the moment is a finished whiskey, and that out of the bottle has an alcohol content of 40%. That's what's stamped on it for the HMRC here in the UK. But it's been open to atmosphere for a few days now, so some of it has evaporated and I've lost that to the Angel. Now the full range is there, but as I said, the over the full range it's not linear, so we've got some uncertainty. So what I can do is click on this hidden screen, and if I set this to my transfer and blending, which is the finished product, you'll see now that the accuracy has shifted closer to 40%, and that's because I've homed in to a more precise ABV part of the OIML tables. So that one's pretty easy to understand. We also have a process for column stills, so this could be making whiskey, vodka, maybe gin here in the UK, but it tends to be a lot hotter than your conventional pot stills, so it's another curve. All of the ABV measurements are referenced to 20 degrees C, and because I am nowhere near the temperature that we should have on a column still, you can see at 10 degrees, I've introduced a lot of error because I'm using the wrong ABV curve. Okay, so there's one there. There's also a one for pot stills. So if I come now to my pot still, now this is the one that is a challenge because I have the requirement for 2 ABV ranges. So the cut would be up in the 60s. So we have got a different range to the transfer and blending. But what it will do, it will monitor this ABV value. And as this decreases, as we go through the process, we will see this automatically change. At 25%, it will change to the pot still low range, and that will maintain your 0.1% accuracy on your ABV. And all of the time it's calculating that tax cost. You can ignore that obviously for the different production parts, you know, so from your wash still to from your pot still. It's really the finished product that we're looking at that cost. And we also have the option to manually reset the totalizers, but of course we could automate that quite easy because it's sat within a PLC. We have built-in trends on all of these, so there's not much happening, and it still refers at the top to what range you're on. If I exit that and look at my trend for this one, I will see my different ranges. So you can see there, that's where I changed my ABV curve. So there you have it, one Coriolis meter for all of your distilling needs. And of course we at Siemens, we understand the traditional methods are still important to manufacturers. So the beauty of this is rather than having a big Coriolis meter with a bright display that sticks out and everybody can see it, we can have a Coriolis meter that just looks like a piece of stainless steel pipework hidden away, and then this part of the process can be taken away into a control room somewhere. So it doesn't affect when you're having your tours that you look like you're spoiling the process. But in fact, what you're doing with this is because this is repeatable and we're not introducing human error on the measurement, you're going to have a repeatable product, and that is always going to help with the quality of the end product. So there you have it, one ABV transmitter to cover all of your distilling needs. I hope you enjoyed the update on this product. Thanks for listening.